Hello everyone, welcome back to my channel. So in this video we'll be revising our Python Pandas topic of class 12th IP. We'll be revising all the important topics like series and data frame. So let's start. So first of all, Python Pandas was developed by Wes McKinney in 2008. Now this is also an important question, that who developed Python Pandas. This was there in the CBSE sample paper also, and it was developed in the year 2008. So Python Pandas basically is an easy and efficient data analysis and data manipulation tool which is used in data science, thereby helping in decision making. Now some of the features of Python Pandas are as follows. They support many kinds of formats. They give you a good input output. They help you in finding and filling data, like you can perform different types of slicing in that. Then they support selecting subsets of data from bulky sets, and you can do group by operations also in the Python Pandas. So the next is the data structures. So now what is this data structure? Now basically it is a specialized format of organizing, processing and retrieving and storing data. Now we have got three types of data structures over here: series, which is one-dimensional; data frame, that is two-dimensional; and panel, which is a three-dimensional data structure. But according to our syllabus, we will talk majorly about series and data frame only, that is the one-dimensional and the two-dimensional. We are not going to talk more in detail about panel, but we should know that panel is a three-dimensional data structure. Okay. Now about using pandas. Now you can import the pandas as import pandas as an alias name. Okay. Suppose whenever you write a program, you import pandas as PD. Okay, you can import pandas either as PD or P or any other identifier that you want to give according to the naming rules. So usually we write that import pandas as PD. You can use anything. So that is how you import it. This is called as an alias name. Okay. Now talking about series. Now what is series? Series is a one-dimensional data structure which has got homogeneous data type. Now it can store different types of data type, but in one single series you will have only one type of data, not different types of data. So this is one important difference that you get in series and data frame, that series will be one-dimensional and data frame will be two-dimensional, whereas series will store homogeneous data type, and your data frame is going to store heterogeneous data type. So this is one important difference. So it means basically it contains series of data, and with indexing starting from 0 to n minus 1, where n is the number of elements. So 0 to n minus 1, basically it means that suppose if you see here, this is a series which is given over here. Now in this series you have got the elements 10, 20, 30, 40, 50. So how will the indexing start? The indexing will start from 0. So 0, 1, 2, 3 and 4. So as you can see, there were 5 elements over here, and the indexing started from 0 and it has gone to n minus 1. N over here is 5. Total we had 5 elements over here. So n over here is 5 and our last indexing is n minus 1, that is 4. So that is why we say that whenever there is indexing in series, it will be from 0 to n minus 1, and n will be the total number of elements. So here you can see in this example, we are printing our series, that S1 here is our series name, and we give pd.series. So here pd is our alias name. So before giving that pd.series, we have to import pandas as pd. So we should not forget to write the statement that import pandas as pd, and then only we can write the statement of series. So pd.series, and then we have to give this brackets, and in that you can see I have given a list of values. And when you print S1, you will get this output. Okay, the series will be in this way. So this is a one-dimensional, and here the data type is given as integer. Okay. Now here, as you can see, I have given print S1 of 2. Now what does this mean? This means that I am asking to print the second index. Now in the series, what was the second index? Now this was 0, this is 1, and this is our second index element. So I have given S1 and then I have given the index number. So at second index, the element here is 30. So 30 will be printed. So that is how you do the accessing in series. Now what is slicing in series? It basically means that we are extracting a particular subset or a particular part from your series, and the syntax for that will be the starting point, the ending point, and this is the progression, or you can call it as step value. Okay, so your starting point, your ending point, and your step value will be there in the syntax. So that is how we do it. Now it extracts values from the start index to the end -1 index, progressing by progression. Okay, that is according to the step value. So basically, if you give, suppose you give the statement as print the series S1, and you have given the index as 1:3. Now it will start printing from 1, it will print the first index, it will print the second index, but it won't print the third index because it will exclude the last index, whatever you have given in that syntax. So excluding the last index, whatever the leftover index from the first one, that will be printed. Now suppose you have got a series in which there is 5 elements and the indexes are 1, 2, 3, 4 and 5. Okay, now if you have given a kind of slicing like 1:5 you have given, and then (2) you have given. Okay, so this is, suppose you have asked to do this kind of slicing, S1 is 1:5:2. So that is your indexing. This is the index given by you. Now what will happen basically is that it will start from the first value and it will go to the fifth value, but in this case you have given step value also. So the first number that will be printed, the first element that will be printed will be of the index 1. Then you have to do 1 plus 2. So 1 plus 2 is 3. Then the third index will be printed. Now 3 plus 2 you have to do for the next one because the step value here is 2. Now when you do 3 plus 2, the element which comes is 5. But we cannot print 5 because 5 is the last element that we have given and we have to exclude the last index. So in this case, the elements that will be printed will be of the index 1 and 3. So whatever the corresponding elements are there that are having the index 1 and 3, they will be printed in this case. So that is how you do the slicing of series. Now talking about some important object attributes, we have got index, in which it will return the indexes. In case of, if you give the values, it will give you the values. Now dtype basically means when you ask for the dtype, it will give you the data type of the values that is stored in the series. And in case of n bytes, it will give you the number of bytes of the data. In case of size, it will return the number of elements. Okay, so whenever you ask for the size of your particular series, you will get the total number of elements in that series. Like in our previous case, we had 5 elements, 10, 20, 30, 40 and 50. So the size of the series was 5. Now in this case, it will return 2 if it has got NaN values, that is not a number value. Now talking about some important functions. Now we have got head and tail functions. Now this head function will return you the first n values or the first n rows in case of series, and the tail function will return you the last n rows. Now the predefined value for this head and tail is 5. Suppose if you give the syntax as head 3, that means your output will be the first 3 rows. But if you're giving it as head and then only the brackets, you have not specified any particular number of rows, then it will print first 5 rows because the default value of head and tail is 5. So in case of both, you will get 5 as the default value. So that is how it will be printed. Then you have got ILOC and LOC. Now these two are a way of slicing or a way of extracting information from the series. But in case of LOC, it is the label based indexing, and in case of ILOC, it is the index position. Okay, the index position that is already defined, that is from 0 to n-1, the indexes which you have. According to those index, you will do the slicing in case of ILOC, and you will exclude the end index. Whatever the end index is given, you will exclude that, and you will print it from 0 to n-1. That is how you do in case of ILOC. Now in case of LOC, LOC is the one in which you do the label based indexing. That is, whatever is the row label is given, according to that you will do the indexing. But in this case of LOC, whatever the end label that you have given, that end label will also be included in the output of your program. But in case of ILOC, the end index, integer position index which you have given, that will not be included. So that is one difference in case of LOC and ILOC. Now some mathematical operations which we can perform on similar indexes will be, we can add two series, we can subtract them, we can multiply or divide them, provided that the indexes are same. So whenever you add two series or you subtract them or multiply or divide, these kind of operations will be followed on the elements that are having the same indexes. So if you have two different series, you are adding them, then the elements with the same indexes will get added. Then you have got drop and pop methods to remove the elements from the series. Now let's come to data frame. Now what is a data frame? Data frame basically is a two-dimensional structure. Okay, it is a two-dimensional data structure which is storing heterogeneous data type. So in case of series, it was a one-dimensional data structure, but data frame is two-dimensional. Series was holding homogeneous data type and data frame is holding heterogeneous data type. So data frame will just be like your SQL tables or your Excel spreadsheets. Like here, there's an example of a data frame. This is a data frame. So it is just like a table form, just like you have in your SQL tables or your Excel spreadsheets. And in case of data frame, both your row and column indexes will start from 0. So you have got row index also and you have got column index also in your data frame, and both of them will start from 0. So for creating data frame, you use this function data frame, and one thing which is very important is that the D and F which is present over here, they should be in capital letters. If you write small d and small f over here in data frame, then your data frame will not be created. Like for example, here we have created a data framed, this is the name of the data frame. So we have given pd.dataframe. So again you have to import, you have to write the statement that import pandas as pd. Only then we can use this pd. Okay, so don't forget to write that. So this is our data frame, and then we have given pd.dataframe, that is how we are creating it. We have given the brackets, and in that we have given a dictionary of values. Okay, so in this dictionary, as you can see, the name and the marks. So name and marks are the column, and these are the values that will be present in that. So when you're going to print this particular data frame, this is what you're going to get as output. Your name and marks will be the column headings, that is the keys of your data frame are the column headings, and the particular values which you have given inside, they will be printed like this. So this is going to be the output of this data frame, and the 0, 1, 2 is the row indexes that have been assigned by Python. Okay, now I'm going to perform some kind of slicing in this. Now as you can see over here, these are two different slicings. So in case of this, I've given the data frame name and I've given a closed bracket from 0 to 2. Okay, so this is an integer, this is the index based slicing. So I have to start from 0 and I have to print 0 and 1 index values, and the second index value will be excluded because we don't include the last index. So in this case, as you can see, 0 and 1, these are the two values, 0 and 1, that is Preeti and Reena. So as you can see over here, Preeti and Reena with their indexes 0 and 1 are going to be printed. Now in the second slicing, as you can see over here, I've given the data frame name and then I've given in the bracket name. This name here is my column heading. So here the column heading name will be printed, that is Preeti, Reena and Sunil will be printed in this case. So that is how you perform the different kind of accessing in data frame. Now talking about some important attributes, you have got accesses which will display your row, index and your column labels, and then you have shape. Shape will give you the number of rows and columns. For suppose if I ask you for the shape of a particular data frame, it will be in the form of a tuple. The output will be in the form of a tuple. Suppose it is 2, 3. It means that it has got 2 rows and 3 columns. So that is how you get the output of whenever you give this shape attribute. Okay, so here it means that there are 2 rows and 3 columns and it will be in the form of a tuple. Now endim will give you the dimension, and size will again return the number of elements. That is how, like in series also, when you gave size, you got the number of elements. Here also you'll get the number of elements. Now in order to find the size, you just have to multiply the number of rows into the number of columns. Suppose if there are 2 rows and there are 3 columns, then my size will be 3 2s are 6. Okay, my size will be 3 2s are 6. Now talking about addition of columns. So that is how you're going to do. Like suppose you have already made a particular series data frame, like in the previous case, and now you want to add a new column. Like I have already made a data frame in which I have got name and marks. Okay, I have given names here, and marks is okay. So this is my already made data frame. Now I want to add a new column which is roll number, and I want to add the numbers 1 2. Okay, so what will I do basically here is that I will give the name of the data frame. Okay, here one more value will be there, and here roll number 3. So I want to add this particular roll number column over here. So I will give the name of my data frame. I will give a closed bracket. Okay, closed bracket. In that closed bracket I will write the name of the new column that I'm supposed to add, and then I'll give a equal to symbol, and with that I'll give the list of values that I want to add in that particular new column. Suppose here I want to add roll number, so I've given the roll number list which I'm going to add. So that is how, if I give this syntax, then my new roll number column will be added, and this will be my new data frame. Now talking about some iterations, we have got iter rows and iter items. We even have iter tuples, but iter tuples is not there in our syllabus. So in case of iter rows, it will iterate row wise, and in case of iter items, it will iterate column wise. Now we have some functions and methods, and this is similar to that in series only. We have head and tail functions, which we have just talked about. It will be same in case of data frame also, that first n rows and first that is in case of head, first n rows will be printed. In case of tail, last n rows will be printed, and the default value for both head and tail is 5. That is, if you don't specify any particular number of rows, then the first 5 or the last 5 rows will be printed. Now in case of ILOC and LOC also the same thing is there. In case of LOC, it is the label based indexing. You give the column name, and the whatever the last column name is there, that will also be included. But in case of ILOC, you give the integer, that is the index based position, and in that the last index will not be included. Okay, the last n-1 index will be included. So it's similar to that in series only. Now to remove the particular rows or columns, you have got here pop, drop as well as del. Now talking about Boolean indexing, data frame may also be created with Boolean values as your indexes. Now what is Boolean value? True and false. Okay, they have two Boolean values, true and false. So you can create the data frames with your Boolean values as your index. Okay, it basically means that you can provide your own indexes also apart from those 0 to n-1. Suppose here I've created a data frame. Okay, this is, suppose here this is my dictionary, and this is the name of my data frame, my df, and I'm going to give the statement pd.dataframe. I'm going to give the brackets, and in that this will be my dictionary, which will give the values, and I'm specifying the index as true, false or true. If I don't specify the index, automatically we'll get the normal indexes, that is 0, 1 and 2. But if we specify the index, true, false and true, that is how it's going to specify. So that is Boolean indexing. Now talking about some more important methods, we have got insert and append method. Insert method, basically this function is used to insert a column at a specific index of a data frame. Okay, if you want to insert a column, you can insert with this kind of insert method. And in case of append, you can add the contents of one particular data frame to another data frame. So that is how you can use insert and append. Now talking about the Csc files, Csv is nothing but comma separated value. So these kind of files, in this you have got basically two main operations. First is to write the data frame data to the Csv file. For example, you have already created a data frame in your Python program, and you want to you want to take that data from the data frame, and you have to import it to a CSV file. So for that you have this function to_CSV, and how you will give it, you will write the data frame. df here will be the name of the data frame, and you will write df.to_CSV, and this will be the path of the or the location of that particular CSV, that is where you want to save that CSV. Okay, so that is how you will transfer your contents from the data frame to the CSV file. But if you want to do the opposite method, that is you want to take your CSV file contents and you want to import it in your program, Python program, then you're going to use this read underscore CSV. That is, you will give it as df will be the name of the data frame, and you will give the syntax as df is equal to pd.read underscore CSV, and this again is the location of my CSV file, that is where the CSV file is saved. So this is how you can transfer the contents of your CSV file into your Python program. Now the attributes read underscore CSV, it will have one method also, that is n rows. N rows is equal to n. It basically means that you can print the first n rows of that particular CSV file. And you can use one more method, that is use calls. This is to specify the particular columns that you want to read. Suppose you have got a CSV in which you have columns as name and roll number, and you want to import the contents of this CSV file into your program. Now in this case you want only the name, column. So in that case you will use this method as use cols, and in that you will specify the column name, that is name, so that you will get only the name column to be printed in your Python program. And in case of this n rows, if you specify n rows is equal to 3, so only the first 3 rows of both the columns will be printed in your Python program. So those are the different methods for your CSV. So that's all for this video, and if you have any particular doubts you can let me know in the comment section below. So thank you for watching, and meet you in my next video.